Okay, example 1. The particle is projected horizontally at 10 meters per second from point 1 meter above a horizontal surface. Find the time taken for the particle to reach the surface and the horizontal distance travelled. As with any mechanics question, the key to its solution is a decent diagram showing as much information as possible. So what we have here is a particle that is being launched horizontally off from a point that's above where it's going to land. So it's 1 meter above its point of direction. And when it falls, it's going to fall in a sort of parabolic path. So it's going to do that because as it moves, it's going to have gravity dragging it, attracting it towards the ground. But as it moves, it's going to have this initial velocity. Because it's a projectile, there is no internal propulsion unit. The only impulse or force that's being applied to that to give it any motion from its point of projection is whatever is sending it off at that initial velocity. So because it's a horizontal velocity, we call it, we put a suffix on it, x, so ux we know is 10. We know that at this point the clock starts ticking, and when it hits this point here, which is going to be a horizontal distance x away from the horizontal point of projection, we know it's going to be 1 meter below. And because it's 1 meter below, we generally take the origin to be the point of projection. So 1 meter below that will have a vertical displacement of -1. At this point, t equals t. And we also know that during that motion, the acceleration that is going to happen for that particle is the acceleration due to gravity, and that only acts vertically, and it's always going to pull downwards. So as that moves from the point of projection to the point of impact, its velocity, ay, is going to be negative g. We take the downward direction, the negative y or negative j if we're working in vectors, direction to be negative. So the acceleration due to gravity is going to be -g or -9.8. We also know, because there is no propulsion to this, that is the only acceleration that's going to happen. So there is going to be no horizontal acceleration. So if we look separately, if we consider the x direction, what we have from a constant acceleration formula set of details, we know that sx, the horizontal displacement, we're calling x. We know that ax is 0. We know that the final velocity, because there's no horizontal acceleration, is going to equal the initial velocity. So if we need a relationship between final and initial, then we have that. And we know that at the point of impact, the time is t. When it comes to vertical motion, we know that sy is -1. We know that ay is -9.8. And what we don't know is the velocity when it hits the ground. So what's the question asking us to find out? Find the time taken by the particle to reach the surface. Now, whether we're looking at horizontal motion or vertical motion, The variable that links the two is time, because that particle, the time it's at any given position is going to be the same for both sets of equations. So we know that time is relative to t. So if we think about our SUVAT formulae, we want to find a relationship that contains t and one that contains x. So if we use s equals ut plus a half at squared, what we end up doing now is two versions of that, one for horizontal motion, one for vertical motion, and we can store that, we can write that as a column vector. So we're going to have x minus 1 equals u x, which is going to be 10. I'll put that there, like ux equals 10, and uy equals 0, because the initial velocity is happening entirely in the horizontal plane. So the u part of this is going to be 10, 0. T is common to both, plus a half, and then the a part of it will be 0 and minus 9.8 for g, t squared. So that equation there is basically giving us a line for horizontal and a line for vertical. At that point we can separate it out, because if you look at the horizontal part of that, so if we consider the x direction, we've got x equals 10t, and then t squared times 0 times a half is just 0. So that gives me a relationship between x and t. We call that equation 1. And then in the y direction, I've got negative 1. This is 0, and that's going to be a half of 9.8 minus 4.9 t squared. So I have a pair of simultaneous equations which are straightforward to solve, because from equation 2, so from 2 we get t is going to be 1, that divided by that square rooted. So minus 1 divided by minus 4.9 square rooted. So square root, fraction inside, we don't need to worry about the minuses because they become a plus, so 1 over 4.9 equals that, and it should be plus or minus 0.45. However, because the context of that variable is t for time, it's only going to be positive. So it's going to be plus 0.4517 dot dot dot. Because this calculation has included a measure for acceleration due to gravity, which has been rounded to two significant figures, we should always give our answer correct to two significant figures. So for this, our answer to two significant figures is going to be 0.45 seconds and 2 sig fig. So in mechanics, whenever a calculation has involved a rounded version of the acceleration due to gravity, we give our answers to the same degree of accuracy that were in the original, we've been provided for the acceleration due to gravity. So t is 0.45 seconds. We then put that into equation 1, and we're just multiplying it by 10 here, so it's not a huge thing, but the other thing to state is where you are then using this value, this calculated value, to substitute into a different equation, you don't use the two significant figure measure, you use the original calculated measure and then round that once more to two significant figures. So in this case, x is going to be 10 times 0.4517, which is going to be 4.5 meters. So just check that, go back to the question, make sure we've answered the right thing. Find the time taken by the particle to reach the surface, which is 0.45 seconds, and the horizontal distance travelled, it's travelled a total distance of 4.5 meters.